So today we're going to be doing the valence bond theory diagram and crystal field diagram of this complex ion. So just by looking at this complex ion, we know that the charge on the central atom is going to be 3 plus. It's going to be cobalt 3 plus because we know that nitrogen has a neutral charge, so it's going to be 3 plus. We also know that our coordination number is going to be 6. This also because there's 6 ligands, and we know when there's 6 ligands, the shape of the complex is going to be octahedral. And we know that there are 2 types of hybridization that come with octahedral. There could be sp3d2 or d2sp3. So how we can choose what type of hybridization we get is by looking at the ligand. So the ligand in this case is NH3, and we know that's a strong field ligand. So we know that there's going to be a hybridization of D2 sp3 because strong field ligands allow for pairing, so those inner d orbitals are going to be free. So for starters, we know that the cobalt 3 ion is going to have 6 electrons, and then we know because we said this is going to be a strong ligand, so we're going to have pairing energy. So because we have to add pairing energy, there's going to be an excited state that we have to add here. So the excited state is going to move all these electrons to pair together like this one. So we're going to have 1, 2, 3, 4, 5, 6. So now you can see that there is space for hybridization on the inner d orbital. So we're going to have D2sp3 is going to hybridize. And we're going to put that right here. We're going to put our 6 electrons, and we're going to put our new bonds. And then we label these as, this is going to be 6 NH3 plus sigma bonds. And we can't forget to write right here inner d orbital. So for the crystal field diagram, we're going to go back to the regular form of cobalt 3 in terms of electrons, and we're going to spread them out because NH3 is a strong ligand. We know that there's going to be a large split. So this means that the electrons won't go like that and then up here. They're going to fill this up first and then go up there. Okay, so there's going to be 1, 2, 3, 4, 5, 6. And that's going to be it for the crystal field diagram. These show where the bonding and pairing is going. And we're going to note that the splitting energy is going to be greater than pairing energy for a large split. Also too, we're going to note that this crystal field and valence bond theory is going to be diamagnetic due to the fact that both right here, and on the last one of the valence bond theory, all electrons were paired up and nothing was left looking like this.